Okay, here I'm showing you two examples of what might be left after 3 rounds of reproduction. So for this particular scrapbook paper, that's what I ended up with. Oops. Okay, which makes sense, right? And then for this particular scrapbook paper, this is what I ended up with. Okay, now sometimes it may not actually match. A lot of times I'll see like orange shows up on a green paper because the orange was a better match to the dull green than the bright green was in the box. Okay, so have them graph it. So I've graphed these two scrapbook papers on here. So this was the one with the stripes and the other one was the one with the flowers. Okay, and you're going to have each group share. So this was this one and this was this one. All right. Oops. Try and turn this around for me. Okay, so we're going to have them graph it and we'll talk about it and then ask them, okay, what was the main idea? What did you see? Well, they should have noticed that that the scrapbook paper, or that the dots that survived matched their scrapbook paper. You say, well, why is that? And it should be obvious to them that those that matched the scrapbook paper were more likely to survive, and therefore they were more likely to reproduce, and therefore they are more likely to be the most prevalent in the population. Now here's where you want to emphasize a point. One of the most common misconceptions with the idea of natural selection for students is that somehow the factor that's doing the selecting, in this case the environment, the factor that's doing the selecting is somehow causing the change in the population. Now, let's think about that. Is it causing the change in the population? Well, yes, it's causing the population to change in its frequency of different alleles, but it's not actually causing the change. So you would ask them, all right, in this environment, did the dots that were orange mutate to be green? Did the dots that were purple mutate to be teal? And obviously no, they didn't mutate. Wait, so you mean if I put a pesticide on weeds, it doesn't cause them to become pesticide resistant? Pose that question to students, have them think about it. And when you look at it this way with the dots, well, obviously not. No, it didn't cause the mutation. It caused those who already had the mutation to become more common in the environment. Okay? And so emphasize that. We didn't have the dots here that were yellow didn't spontaneously turn pink. They just died. And so when natural selection happens, it does not, whatever the selecting factor is, it does not cause mutations to occur so that the individuals change. It simply selects for those individuals who already have a beneficial mutation in that. And so that's why we say that populations evolve, not individuals, because individuals can't change, but a population can change in its allele frequency over time. All right? So that's part 1.